Next, I would like to show the recap video clip of Thailand Japan Student ICT Fair 2019 in Princess Chulaporn Science High School, Mukdahan. Please enjoy.
But we can use it as a service through a cloud-provided navigation. User interface gonna be changed. Okay, you can use your voice. You see it.
Modern technology allows people to communicate directly. The uses of blockchain technology are endless.
Maybe we have many projects.
It output the incorrect sound.
You can write your report and you just say that this topic needs to be addressed in the future.
It is used to enjoy us and parent science.
This change enabled people Venus, Mars, and Jupiter. Then we carry out questionings.
Please give a big round of applause for both video presentations. The panel talk will begin shortly. At this moment, please feel free to go to the toilet, which is located at the back of the hall.
Now we are ready to begin our session. Good morning, Professor from Mae Phá Luang University, distinguished guests and our attendees. We are delighted to welcome you all to the Resourceful Talk panel this morning. My name is Chutimon Siapiang.
And I am Kantisha Tuipala.
We are the MCs for this room. This is the second day of Thailand-Japan Student ICT Fair 2022. Today, there are 5 parallel presentations happening after the morning panel. Please feel free to join any room as you wish.
And in this panel room, our guest speaker is from Mae Phá Luang University. She is an expert in data science, machine learning, and Ibala data classification. She has been a lecturer at the School of Information Technologies, แม่ฟ้าหลวง University. For her latest publications, just to name a few, include, first of all, computer vision and machine learning for medical image analysis. In addition to that, antimicrobial resistance and machine learning.
All right, ladies and gentlemen, may I invite Dr. Patharamon Wuthipithaya Mongkol, Assistant to the Dean of School of Information Technology, Mae Pha Luang University, on the stage, please.
Okay, so good morning, distinguished guests and all the talented students. It's a cool morning, right? So I received actually the handbook of this event just this morning, an hour ago. I flipped through it. I saw a lot of your works, and it surprised me. Really, you guys are really talented and probably know a lot about machine learning already. Okay, so let me introduce myself again. My name is Patharamon Wuthipithaya Mongkol, and you can call me Ajahn Phon or Phon for short. And also, I forgot, I practiced this Ohayo gozaimasu, if that is correct. So welcome all the Japanese students as well. Okay, yeah, today's topic is machine learning, a big step into the future world. Actually, I thought about it just yesterday, and I think I would be wrong because it's no longer the future world. It's actually today's world. Okay, this topic is, I would say, one of the hottest topic in the research field so far and recently. And I can confirm that from a lot of your works that you are going to present just right after this, right? There are a lot of machine learning related works, and that's impressive, really. And do you know how hot this topic is? It's not only about in the research field. 2 years ago, before I finished my PhD in the UK, I was waiting to take it's like my final exam, we call it the defense exam, to finish the PhD. So I had a few months before I had the exam. So I was looking for a part-time job that is related to machine learning, and I found a lot. There were actually a lot of positions in machine learning. You couldn't imagine that. There were a lot more positions than people who work in machine learning. So the job was very well paid. And I still believe it's still well paid now. Do you think how much, in average, that they paid per hour? Per hour. That was in the UK. I was looking for a job around London. It wasn't the city that I lived in, but there were a lot of job positions there. The average pay that I found was £400. How much is it? You multiply it by 40, right? You get 16,000 baht, 16,000 Thai baht. And that is not per day, that is per hour. And what am I doing here? Why am I here? Yeah, because the COVID hit us. If you remember, in early 2020, right? That's when the COVID hit us hard. And yeah, all my dreams just went away. But anyway, so I have been I've been continuously working on machine learning. And yeah, that's actually a work that I'm going to let you see that I work with Italy doctors during the spread of the COVID-19. Okay? Oops. Sorry. Okay, thank you. Let me introduce myself a little bit again. Actually, my background was in electrical engineering. I saw some of your work on IoT devices as well, on some circuit stuff. That's impressive as well. So I did my bachelor's and master's degrees in electrical engineering in the US. I didn't like it much. Well, it was okay. Yeah, but hopefully some of you like it, but it wasn't me. So I came back to Chiang Rai, actually, in 2013 and became a lecturer at Maphalung University. Okay, and 4 years after I discovered myself that I was interested in machine learning. During that time, that was in 2016, that was still a new era for machine learning, right? How old were you? 2016? That was 6 years ago. You guys were like 10 years old? Okay, yeah, that's when I started doing research or started my interest in machine learning. So I spent 3 years doing my PhD in the UK, and yeah, since 2013, I've been a lecturer at Maphalung University, and the MC already introduced me. My research interest is on machine learning, of course, data science, and my specialize is on imbalanced data classification. Okay, that's one of the biggest problem in machine learning. Okay. So first of all, let's go into a little bit of the definition of what machine learning is through this diagram. As you can see, that the biggest circle here is artificial intelligence. I'm not sure in your age whether you are more familiar with artificial intelligence or AI or machine learning, but in my age or your teacher's age, maybe, we are more familiar with AI. Okay, that's why I brought up AI here. But I'm still not sure if we got the right concept of AI or not. But anyway, I'll give you the definition of both AI and machine learning in a bit later in the next slide. But before that, as you can see, machine learning is actually a subfield in AI. Okay. Yep, there's some AI part that doesn't need to be machine learning. And you can see other terms as well. We have deep learning, which is a method, actually a method, one of the machine learning methods. Okay. And also we have data science and data mining. Okay. I'm pretty sure some of you know this, but now let's focus on AI and machine learning. If we talk about AI, what would you think of? Robots? This is all about robots. Does AI need to be robots? Not necessarily. Okay? AI is not about robots. It's actually a computer. It can be just a computer, a simple computer, but with the techniques that make that computer mimic human behavior. Okay, so anything that involves making the computer mimics human behavior, we call it AI. What about machine learning? So machine learning is about AI as well, but it's about computer learning things automatically, okay, through the past data or past experience. This may be boring to some of you because you already know the definition, right? Oops, sorry again. But for some of you who are not familiar with machine learning, let me introduce you to this word, classification. Can I actually see your hands who did classification work for this event? I saw some, at least. You have the smart shopping cart, right? So who used machine learning? Who is going to present work about machine learning in a bit later? Well, I saw a lot more work than that. Okay, so, well, classification is one of the most used machine learning method, okay, and the most popular machine learning method. That's why I brought it up here. If you don't know what classification is, let's learn through this slide together. So, here I have, how many images? I have 14 images. And I have marked 4 of them as tufas. Do you know what tufa is? Me neither. It's okay. You don't have to know what a tufa is, okay? But just that, make sure you know which one is tufa, which one is not. Okay. So whatever that is not masked with tufa is not a tufa. Okay? Are you learning? Okay. That's enough time. And now I would like to test you. Okay? For the rest of the images here, can you help me count how many tufas do we have? Can you see? Help me count how many tufas do we have? Excuse me. How many do you get? I saw your hand. 5? Who got more than this? 7? Got 6? 8? Why you got different answers? Because you learn differently, right? Probably not including this 4 though. Okay, so let's see, for example, the first one. Is it a tufa or not? It's not a tufa. So let me give you the answer. I got 1 tufa here. Okay, you got the same. 1, 2, 3, 4, 5. Okay, that's 5 tufas. It's okay if you got it wrong, because probably the images are not clear enough, or you are too far away. But we have 5 tufas here. What was the process inside your brain? You have any idea? Maybe you know it because you like biology, but not me. I don't know what is going on in my brain while I'm learning this thing. Okay, I know that in my brain there are some neurons, there are some nerves, right? And actually, if I compare, your brain is the machine, okay? Machine learning, if you hear this word, the term machine actually refers to a computer, not a machine in like a factory or something. This, it means a computer, okay? And how it learns is that it will learn from the training examples, right? It's just like in your brain, you have to learn from some examples first. And then there will be a process going on inside your brain. And then when I tested you, you could tell me which one is too far or not. Machine learning algorithm is the same. And it's actually a black box. Just like I don't know what is inside. Well, I actually know, but if you are working in this field, it's not necessary that you know the process inside. What you want to get is that the output here is a function, mathematical function, that is generated by a machine learning algorithm, okay, to map the output to the input variables. That's it. You don't have to write out your code to get this mathematical function. A machine learning algorithm will do that for you. And luckily, there are a lot of machine learning algorithms available on the internet. Okay? What about, well, I mentioned programming. Do you know programming? Yes? I think you guys here have learned programming already. So what is the difference between traditional and traditional approach, which is programming, and machine learning? For machine learning, you still have to write some program. Of course, you have to write some code, but wouldn't be as much as traditional approach. Okay. For example, for the traditional approach, when you do programming, you have to write every single line of code, right? But before that, you have to plan out, write out your flowchart and everything, right? Is that fun? You shake your head, probably you hate programming. But for machine learning, you wouldn't have to write that much. Still have to write some code, okay? Yeah, for machine learning, the machine or the computer will do that automatically for you. What about the data that we use in machine learning? We use tabular data. What is tabular data? It's the data that can be put in a table form. Okay, what else? Images in videos. Why do I put images and videos together? Because when we do video, for example, video classification, we actually use the concept of image classification, which is use a shot by shot of the videos. Okay, and that's pretty much like image classification. What else do we have? We have speech. Have you heard of speech recognition? No? It's okay. And also we have text. Just like speech, we have text recognition and so on. That's pretty much all the data types that we can use machine learning with. Oops. Sorry again. Can we turn on the sound for this, please? Do you have sound for this? If not, it's okay. It's okay. I think everyone know what Siri is, right? You're familiar with Siri? A mean one, right? The AI based.
What's 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
What's 0?
Oops. Let me play that again. Oops, it's okay. Never mind. Yeah, but that's Siri's response. That was quite mean. And it's someone who doesn't really answer your questions, right? You know, Siri like that. What is it called actually? It's actually the voice assistant. What else do we have? We have Google. Okay, when you call out Google, you say, hey Google or hello Google, right? What else? We have Alexa from Amazon, and we have Cortana, and any other voice assistants available in the market as well. How is a voice assistant so good at arguing with you? How are they so good at arguing with you? They were improved using machine learning. Okay. Through the information or maybe through your conversations, through the conversations with you. Okay? And actually, do you know that they have been with you over a decade? Do you know when Siri first came out? Any guess? No idea? You were too young. That was in 2011. 11 years ago. You were like 6 or 7, right? Yeah, that came with iPhone 4S. And later we had Alexa in 2014, but that's not on the phone. Another interesting event was with AlphaGo. Anyone knows AlphaGo? Do you know? Okay, very good. Someone knows what AlphaGo is. Do you know Go? Not sure how to pronounce that. The Chinese chess. The Chinese chess with black and white ships. Yep, we call it Go, right? Or Go in Thai. AlphaGo was created by Google. Actually, Google DeepMind, to be exact. And there was an event, actually a match, of AlphaGo with the world champion from Korea. Do you think who won? Do you think who won the match? AlphaGo? Definitely. AlphaGo won the match. But they actually played 4 games. Do you think how many games AlphaGo won? All 4? It's not all 4. AlphaGo actually lost one game, and the mistake was quite stupid. Okay, if you are interested, you can go on Google, on YouTube. There's a documentary on that. It's 1 hour long, if you have time and you are interested. So what else? What are other examples that may be closer to you in daily life? Using machine learning. Who doesn't like shopping? You raise your hand. Probably not your teachers. No, we do shopping a lot. And you have probably used Amazon, right? Well, in Thailand, you may not be so familiar with Amazon because we use, what do we use? Shopee, Lazada, or ask your teachers. They shop every day. Well, for Japanese, I believe you're more familiar with Amazon. So if you search for something on Amazon, for example, the PS5 game, the Spider-Man game, also something will come up. Okay? This is the suggestion of frequently bought items with the game. They use machine learning to do that, to encourage you to buy more, so they make more profits. But actually, if you sum it up, there's no discount for that. Okay, and also customers who will this item before also will this. This is the application of machine learning as well. What about my own work? So this is one of the latest work of mine on machine failure detection, okay, in the industrial. Why is this so important? This is the average cost of downtime. Downtime means the time that they stop working in the factory because there's a machine breakdown. Okay. The average cost was actually in 2016 was $260,000 again per hour of the downtime. That's a lot, right? So if one machine breaks down and they have to stop the operations, that would be a lot of cost. So I found a way to prevent that from happening using machine learning. But there are challenges. You know, machine learning is a new field, so it's actually hard to get accepted from the industrial people. Okay, hard to gain their belief. And also, one of the difficulty is the data. I would say now it's much better because we have moved into digital transformation world. But before, everything was on paper. We only had paper-based. Okay. Now it's better. Still, it's hard to obtain real data from the industry. And also, we have to control. We have to make sure that the data is of good quality and can be ready to process with machine learning. Also, the thing that I'm expert in, imbalanced class distribution. This is normal in machine learning problems. What is it? So in this case, there were much fewer failure cases than normal operation conditions. Okay. That's one of the hindrances for machine learning. This is the actual data that I used. what do we have? We have type. I actually dropped the first column. We have type, which indicate the quality of the machine. We have air temperature, process temperature, rotational speed, torque, to wear. And the last one, last column tells me whether the machine fails or not. Okay. So I use this data to train a machine learning algorithm. Let me just skip to my result. Well, I use a lot of methods, the traditional methods and also some techniques to improve the result as well. If you look at the recall is the accuracy of predicting failure cases. My accuracy, the best one, was 72%. And specificity is the accuracy of detecting the normal condition that was high due to imbalanced class distribution, like I said. So I try to improve the result. This is my own method, published 2 years ago while I was doing my PhD. This is some technique that I apply, and I could improve my accuracy to 91% in both cases. Okay. Let me just go to another example of my work. This is on oil and gas decommissioning. It's another field, totally different fields. So I actually can go into any field, can jump into any field and apply my machine learning knowledge. But the difficulty is that, when you work with people in other fields, we don't understand each other. Probably like I'm talking to you now, you don't understand what I'm talking about, but you do understand your own things well, right? So that's why I need some collaborators. So my collaborators were from the UK and Australia, an expert in oil and gas. And also this is actually my PhD supervisor. He's a nice guy. Okay, so why is this problem important? If you don't know about decommissioning, that's the last stage of oil and gas production. They will have to consider whether they will leave the infrastructure in the sea in place. That means they will leave everything there, or they will remove everything from the sea, or will remove just part of it from the sea. And that decision can take years to do. Let me give you this example. This is a Brent field in the North Sea. This field belongs to Esso and Shell, the two big oil and gas companies. Do you know that they spent 10 years of doing review and planning for the decommissioning? 10 years of work, that's a lot of work. Of course, a lot of labor is needed, and also a lot of expenses as well. Why did it take so much time to do that? Because they needed to involve over 400 individuals from over 180 organizations. That's required by law. And these are the stakeholders that we have to get involved. That's why it took them so long. Okay. Let me just skip to the result. So firstly, I could achieve about 77% accuracy in predicting whether they should leave everything there, or partially remove the infrastructure from the sea. Okay, I wasn't satisfied with that yet. So again, in my next paper, I tried to improve that. And I could push the accuracy up to 88%. I think that's good enough. But like I say, with the company, it's hard for them to believe this thing, right? They have been using other methods for over 40, 50 years. They've been following their own method. How would they believe me with that? Well, this is the last example that I brought with me today. Like I said, during the COVID-19 in 2020, if you remember, in the north of Italy, it was quite sad back then. There were a lot of COVID patients with no beds, not enough medical staff, not enough doctors, not enough nurses to take care of them. And if you saw from the news, they just let some people die, just like that. Okay. So the problem was that there were not enough beds in hospitals, right? And here's a project that I work with some doctors from a hospital in Italy. They actually use all of this protocol, all of these conditions to discharge or let their patients go home. Okay? They have to follow strictly all of these 7 conditions. So there were not many patients that could satisfy or met the requirements. What I did was that I used machine learning to rearrange these conditions. If you can see, so there were 4 cases. So all of these patients were sent back home, and they follow up whether they were healed after that, or they had some symptom, or they died, or they had to readmit at some hospital again. So as you can see, the safe conditions are 0 and 1, right? This is the result of my machine learning work. You follow any path that guides you to 0 and 1, and that would be safe to send your patients back home. For example, this is the oxygen level, the saturated oxygen. If it's above 287, well, you consider this condition again. If it's above 405, that's the oxygen level again. You see, it will come to this part. Well, if you can't see the laser, it's the first block here. So 0 means the patient would be healed, so that is safe to send the patient back home. And can you see that we use only 1 condition for that instead of 7? So they can send more patients back home. Isn't that powerful? Okay. Well, I have been working on other things as well. So, for example, predict possible cardiac arrest in football players. If you are a football fan and you have seen the news of a football player in some European country, I don't remember which country, he died during the play, right? Because of the cardiac arrest. So we can use machine learning to predict that and to prevent that before that would happen. What else did I do? I predict some life-threatening diseases such as cancers, Parkinson's, and so on. Okay, and My current work is on predicting depression in college students. Of course, I use Mae Pha Luang students as case study, and currently I could achieve the accuracy of over 85%, and I'm still working on it. Like I say, the challenges. Well, this is an interesting field and the hottest field. Again, I would just emphasize on this. But, well, it's the hottest field in the research, and also it's coming into the industry. But for now, the challenge is still, one of the challenges is the industrial acceptance. Like I said, they have been using that traditional approach for something. It's not easy to convince them to believe in this thing, but it's not impossible to do so. As you can see in a lot of examples in your daily lives so far, Siri, for example, right? And also we have to make sure the quality of the data is well enough, is good enough for us to do machine learning. And like I say, another one is the communication between people with different knowledge, different fields of knowledge. Okay, but is it too hard? Are these challenges too hard? I would say no. And actually my task today, they asked me to convince you, not sure if I have done so. They asked me to convince you to do more research on machine learning, or maybe like on whatever you are interested in. I would say research is actually the learning process. While you are doing research, you are learning, mostly by yourself, right? That's the self-learn process. And with your research, it's not necessary that you have to get out or graduate and become a researcher. You can work in the industry. You have plenty of opportunities if you are good, at least at research. Okay, so keep on your good work and good luck with your future research. Thank you so much.
Please give a big round of applause once again. Thank you for the resourceful talk, Professor, and please remain on the stage. May I invite Dr. Goson Pesuwan, a steering committee of Princess Julapon Science High School, to give the token of appreciation to Dr. Patharamon Wuthi Pitaya Mongkol, our keynote speaker, please. Thank you very much, Dr. Patharamon and Dr. Goson.
Ladies and gentlemen, the special talk is now finished. Before departing, may I re-inform you that there are the parallel presentations happening at 9 o'clock onwards. So, for the on-site participants, I would like to invite you all to participate in the presentation rooms located at Smart Classroom 1, 2, and 3, Meeting Room 1, and the Lecture Hall. And for online participants, you can join the presentation via the link provided on screen.
Thank you very much for your participation. It's time for departure. For this morning, I'm Chutimon Seapiang.
And I'm Kantisha Tuipala.
Would like to say goodbye for now. I hope you have a great day. Thank you. May I call all students who will present the project in the presentation room first. All students, please stand up and leave the hall in the front gate. All students, please stand up and leave the hall at the front gate. In front of the hall, there will be students from